Good morning everyone. In this video, we are going to see the simplification and minimization of Boolean functions. Come, let's go into the video. So in the simplification, first we are going to see using algebraic expressions, that is Boolean algebra. So there are several methods to minimize the Boolean function. Simplification or minimization can be done using some theorems of Boolean algebra, and this minimization procedures are not unique because there is no specific rules to predict the next succeeding step in each process. Now we are going to take an example to simplify the following Boolean equations. So consider this is the given Boolean function. We are going to solve our problem. First of all, we are going to consider this function, and we are going to multiply these terms so that we will be getting a b bar c dot ab and a b bar c dot c. So in this we are having a b bar term and b term, so this term will become 0, and here we are having c dot c, which can be written at once. So we will be getting a b c bar because of these two conditions. And next, out of the remaining terms, what we are going to do? In this min term, the variable c is missing, so we are going to add c plus c bar in it. Likewise, so when we multiply c plus c bar, and we will be getting abc and abc bar. So from this we are going to take the common elements. For example, from this term and this min term, we could take the common variables a, c. So the remaining term is b and plus b bar. Likewise, from this term and this term, we are going to take the common c bar outside. So we will be getting ab plus 1. So b plus b bar, according to the rule law, become 1, and ab plus 1 also becomes 1. So the remaining terms are ac plus c bar plus a bar. So which we could combine these two terms as ac the whole bar. So when ac plus ac the whole bar, the total minimization becomes 1. So this is our final answer. Next, we are going to simplify our Boolean function using Karnaugh map. So in previous we have used some logic gates or Boolean algebra. When the number of variables increases, it becomes a complexity to solve the simplification. So next method, it was proposed by Karnaugh, so it is known as Karnaugh map. It's a straightforward procedure which regard as a pictorial representation of the truth table. So the Karnaugh map provides a systematic method for simplification and manipulation of a Boolean expression. So for n variables of a Karnaugh map, there are 2 power n number of squares in that pictorial. Each square or cell will represent one of the min term. So now we are going to simplify the following Boolean expression using Karnaugh map. So the function may be given it as sigma 0, 2, 3, 5, 7, 8 likewise. So these are all the cells numbers in which the min term is going to be 1 in all these cells. So how we are going to picturize this in our solution? See, likewise. So we are going to take the 4 variables as wx and yz, and we have dropped the corresponding cell. For example, the first cell is 0. It comes from 0, 0. That is the 4 variables 0 means here, and will be giving us 1. So we could pair it with either 2 1s or 4 1. This is called the quad, and the corners also separately has been quad. Okay, and we are going to write the each minterm for this. First of all, I am taking this one. So when you are consider this 4 ones, we have to take into the variables this variable, this value, and this one. So when you are taking what is the same, when you are having the same one, we have to check. So this one represents x. So in my minterm, I will be having the x variable and this responds to z. So it is x z. And when you are considering this 4 ones, we have to consider only these 2 terms, which is y and z. Okay, and when you are considering these 4 corners, we should be very careful because we have to consider the terms y z bar, y bar z bar, w bar x bar, and this one w x bar. So in this, what are all the common variables when you are taking? We are having this x bar. Here is also the same variable in this side, and when you are considering here, we will be having z bar and z bar. So when you are having these 4 corners, what we are having is x bar and z bar. Okay, so our final answer is you have to sum all these separate product terms, which is w x bar plus y z, and one more, sorry, I have missed one thing. So this one, when you are considering this one, we will be getting w and x bar. So all these 4 terms becomes our solution. This is the maximum simplification, and it's very easy for when the number of variables increases. Here we are having nearly 4 variables at the maximum, and this is the very simplest solution given by the Karnaugh map. Thank you.